I hope this doesn't fail. Last time the voice didn't show. Anyway, what we're gonna do is go to Desmos and we're gonna test this theory out. So, not theory, the idea out because I haven't really tested it out yet, which is a scary part. So let's go over what we talked about or what I talked about. We're gonna talk about the checkpoint theory I made, where we're gonna go for parabola, ellipses, circles, because my major is aerospace. For me, it's more important than most other stuff. Yeah, I did learn it in somewhere in calculus, I believe, but I think it also is in the trig book. So I put it in trig instead of calculus, but we'll see about that. So, this part we know. I mean, it's just making circles. I guess you don't know yet, but who cares? That part's not really the scary part. Yeah, and the geometry part might want to do arc lengths later on, but that's not the point. These points are not really that important. You can memorize them by looking at the cosine and looking at how the sine will react with it. So in reality, the only important one is this one. If the idea is where the focus is. Honestly, this one is the only one that's needed. From that, you can derive all of them. Like for example, this is shifted to like plus pi. You can change the angle, like the shift. Anyways, that's not the reason I'm here. I'm here for is elliptical cases. So if for some reason we have x squared root of 2 plus y squared root of 2 equal 1, we know where that is, and if I change this to 4, we kind of change the whole entire picture of this entire equation. Now if I were to make that into polar, according to what I put over here, this equation should be able to just transfer to polar. So let me test this out. Clearly I haven't tested it out. It's only like an idea until I test it out, right? So there should be a minus and a plus version, otherwise it won't work. And then there's an inverse cosine here. So according to all math knowledge I know of, this should work. R equal R. If it doesn't work, then we have a problem. Now we have parentheses over here. Still have no idea why Desmos is so tricky about the cosine, whatever. But I believe it's cosine square, right? And then sine square over here. I need to brush my teeth again. Anyway, ooh, sine. And that didn't really play out correctly at all. It created an interesting shape, sure, but it did not create what I wanted. What did I do possibly wrong? Well, we know that this is the A and B is correct. We know that the R sine cosine squared is correct. I know what I did wrong. It's because these are not in theta, therefore they assume a different system. For some reason they do that, and I have no idea why they do that. But as you can see, these all work out. So if you don't want to do a focus, we can see that it would work. Why do you not want to do a focus? Focus is much easier, but it's very selfish. As you know, it's very eye-centric. If you're trying to go to something that is not eye-centric in polar system, it's pretty difficult. Um, as you'll see, slowly, we'll see that non-I-centric, me, in language terms, polar is like saying I love myself, I love what I do. That is what polar is, in my opinion. Now, this equation should work now. I'm scared for this equation because as you can see, that is a fudging hassle, and I hope it works. The video quality is good. I think I might pause maybe to make sure the video quality is good, but as you can see, it indeed creates a ellipse. I'm actually quite shocked it works. But um, yeah, I would recommend in this case, because we're not doing focus, doing the rectangular form, because it's much easier than doing the going to what's the word? Going to polar. Because polar makes it more confusing. Now, why would you ever want polar? It's eye-centric for this. So in this case, you would probably not want polar, honestly. Um, the only reason I could think of you wanting polar is for something like this, which is my battery is low. Let me charge my computer while I talk like a nonsense man. Anyways, wait, is my mic working? This has access to my mic, right? It's to be working, so we're just gonna continue. Now, this part is next. I hope it works. So now what we're gonna do in this case, and this is why sometimes rectangular form is more superior, because that way you don't have to deal with focuses. But let's say you want -2 and -3. Now, these equations no longer work. Clearly, it doesn't work. So now you have to go into a dilemma where you have to go with -2 parentheses divided by, well, we could transfer this over here, and then we could just switch it up over here with h, which is h would be 2. So h would be, it would be -2 or just 2. In reality, it would be just 2, because we have claimed over, yeah, it would be just 2. So it would be 2 over here. It would be cosine parentheses angle over here. And then k would be 3, because it wouldn't change much from what it has. So it should be fine. Let me try if this works. Function sine. Yeah, that works. Now, that equation is completely useless right now. Now we have to contain a over there. A is looks like just a cosine square, sine square from my calculation. So it's gonna be something like, well, not that hard. It does create a circle. Note that does, because it just cancels out to 1, which makes perfect sense. I'm gonna delete this. Oh, what the hell? Oh, that is interesting. I might actually want to keep that for more studying. Don't worry about me. I just found something interesting, and when I find something interesting, I do a little bit more math into it. What the actual hell happened here? Whoa! Oh, I get it now. Now, what's happening is this is I don't know what's happening here. I might be mimicking the hyperbola function, but this over here, what's happening is mimicking kind of the perpendicular hyperbolic formula, but because it's has some other function, it doesn't really mimic that all the way, probably because there's an x square over here. So in small angles, it goes down, so this just turns to 1. Yeah, I can see that. I can kind of see how that would work out. I'm not sure if that's true. That's my theory right now. I'm not going. Yeah, it looks like it's functioning as a hyperbola, as its base. Okay, we created. As you can see, we created something off center now. Yeah, we're starting to create that shape. We're not getting to over here yet, which is when this is happening. This should over here, which is 2b squared. Two. Oh, that's an interesting shape. I like that shape actually. This is an interesting shape. I will never forget of that shape. Well, I mean, I might forget that shape. Um, it's supposed to be parentheses here, right? It's supposed to be b squared, right? Yeah. Even if that's not supposed to happen. Yeah. Oh. Okay. Okay. So we got something that's Um, um, that's very interesting. Okay, so we got square. Now we just have to do a minus over here with 4ac. We have A over here, and we need C over here, which I'm thinking I did something wrong. But we'll see, as any other person has said. I think we definitely fucked up. I definitely messed up somewhere, but we'll see. We'll see how much I messed up. Uh, I'm not even getting a function anymore. So yes, I did mess up in the somewhere calculation. Okay. Maybe if minus something, no, plus something is correct. I'm guessing it's becoming an overwhelming negative for here, which is a problem. Hmm. It's a question mark what I should do. I thought this would work. It clearly doesn't work because I did some mathematical error, or maybe I missed the property of r of the polynomial that I didn't really consider, which could be true. Oh, yeah, I forgot this minus one. There you go. So what happened here? I made a mistake. I mirrored it. So if I do a minus here, we get it. But I mirrored it. So I fucked up with a negative sign over here. So for some reason, there's a negative over here that I fucking messed up at. Um, And I'm not allowed to willy nilly put it in there, so there must be a reason. And if I do a minus over here, it won't change anything. Oh, that's an interesting shape. Whew. And I kind of already know why that happened. It's a focal point over here, which we get what we're doing. So some reason there's a negative over there. I don't understand why there's a negative over there. Um, huh, huh. Because I know there's r squared minus h squared is definitely right. HR, this is definitely right. This is definitely right. This is definitely right. This is definitely right. The bottom is also right. So this is also right too, right? Because I shifted all over that one. Here's the mistake I made. So over here, we have a negative. So this would be a negative over here to make a negative over here. We never realized that because over here, then this would be a negative, a positive, so it would be plus. So then we have this situation, which now gives you the right formula for ellipse. I got it. So yes, you should always double check it with the Desmos to see how, where, and what the hell the mistake you made. But I am correct about this. This is off center, and you can see how complex it is in polar form, how idiotic it is in polar form. If you're not selfish, I call polar form selfish for a reason. Because if you're doing polar, if the angle comes from somewhere near 0 0 and goes bounded around it, like it's the middle of the universe, like the sun is the middle of our, like a long time ago, everything revolves around this person, which this person is 0. So like you're studying a body at that point of that's traveling along that object. It makes sense to the idea of pole. If one of the foci is polar, then you do polar. Man, I'm stupid. Anyway, as you can see, that really determines the difference between rectangular and polar. Because if you don't want to do something in rectangular, you, no, if sometimes you don't want to do things in the rectangle, sometimes you want to do it in polar. For example, if you're studying a body and a mass system, for example, if we have something like a planet over here and it's going around here, you would definitely want to use polar coordinates and do an integral polar if you want to make time, what's in Kepler's law. if you're doing something off base, like multiple ellipses and multiple like coordinate systems, in my personal humble opinion, the best way to do it is in rectangular form, because you could have another ellipse over here, ellipse over here, ellipse over here, ellipse over here, and figure out it that way in this method, and not do it in this R method, which there's value to this. I'm not saying there's no value to this. You could definitely try to figure out the value of this. Um, I'm not personally going to try to find the value of it because it's a pain in the ass. In my opinion, the value probably has to do with Remus sum. Probably, if you're trying to do some, I mean, not even Remus sum, I would do no revolution around something. But yeah, it would be interesting. Yeah, there's some value. I still haven't figured out the value yet, but there could be a value for this. I don't see the value in this yet. Maybe someone else will. But rectangular form. Interesting, interesting, interesting. I am very interested in this. Huh. Huh. Okay. It works. Yeah, the important part is that I figured out that it works. This formula over here works, which is quite impressive. Why is it not clicking? That's because okay. Which means my textbook is correct. You always want to double check your shit, right? So I did double check my shit, and I'm correct. As not usual, actually. Most of the time, mathematicians are wrong. Anyway, I'm a engineer, so I can be wrong all the time. Anyway, whoa. Anyway, I'm trying to clean up my shit because it's so messy. As you can see, it's very messy. But I'm getting cleaner with the topics. It's much more readable now. Yeah. Anyway, I hope you like the idea of polar and you actually understand what I was spitting out. Um, Now I'm gonna have to title this video. What should I title this? Probably something like ellipses in polar with offsets, offset ellipses. Um, what should I call it? No idea. Fuck this. Whatever. I'll figure it out.